Next, we'll discuss the body's immune response when there is presence of a pathogen. So once a pathogen is recognized within the body, mucosal tissues are a major barrier to the entry of pathogens within the body. The IgA and sometimes IgM antibodies in mucus and other secretions can bind to pathogens, and in the case of many viruses and bacteria, neutralize them. Neutralization is the process of coating a pathogen with antibodies, making it physically impossible for the pathogen to bind to receptors. Neutralization, which occurs in the blood, lymph, and other bodily fluids and secretions, protects the body constantly. Neutralizing antibodies are the basis for the disease protection offered by vaccines. Vaccines for diseases that commonly enter the body via mucous membranes, such as influenza, are usually formulated to enhance IgA production. Immune responses in some mucosal tissues, such as the prior patches seen in the picture on the left of the screen, in the small intestine, take up particulate antigens by specialized cells known as microfold or M cells. And then we'll move on to defenses against bacteria and fungi. The body fights bacterial pathogens with a wide variety of immunological mechanisms, essentially trying to find one that is effective. Bacteria, such as the ones that cause leprosy, are resistant to lysosomal enzymes and can persist in macrophage organelles or escape into cytosol. In such situations, infected macrophages receiving cytokine signals from Th1 cells turn on special metabolic pathways. Macrophage oxidative metabolism is hostile to intracellular bacteria, often relying on the production of nitric acid to kill all the bacteria inside the macrophage. Fungal infections are largely opportunistic infections that take advantage of suppressed immune responses. Most of the same immune mechanisms effective against bacteria have similar effects on fungi. So for parasites, I won't focus too much on that one. Just recognize that it's the IgE-mediated response, so it's the same as allergy and asthma. Eosinophils are involved as well. That's all you really need to know for that one. And then defenses against viruses. The primary mechanism against viruses are NK cells, interferons, and cytotoxic T cells. Antibodies are effective against viruses mostly during protection, where an immune individual can neutralize them based on previous exposure. Antibodies have no effect on viruses or other intracellular pathogens once they enter the cell, since antibodies are not able to penetrate the plasma membrane of the cell. Many cells respond to viral infections by downregulating their expression. This is to the advantage of the virus, because without class 1 expression, cytotoxic T cells have no activity. I won't go into too much detail on any of the other pathways, but I will say that hepatitis B and C are treated with interferons because they slow viral replication. Okay, I do want to focus on the evasion of the immune system by pathogens. So it's important to keep in mind that although the immune system has evolved to be able to control many pathogens, pathogens themselves have evolved ways to evade the immune response. So this is where we'll see antibiotic resistance come into play, and the importance of making sure that your patients are taking their antibiotics for the full dose of time. Bacteria can also evade the immune system because they exist in multiple strains, such as Staph aureus. Is commonly found in skin infections, and then you also see MRSA with staph. Another method of immune evasion is mutation. Viruses' surface molecules mutate continuously. Viruses like influenza change enough each year that the flu vaccine for 1 year may not protect you against the flu common in the next year. There's another form. The pathogens take genetic recombination. We don't really need to go into detail on that one. And then pathogens can also produce immunosuppressive molecules that impair immune function, and there's several different types. Viruses are especially good at evading the immune response in this way. And one of the viruses that does this very well is HIV.